And so while we're opening to page 14, we'll have a look at the calendar. So we're just finishing up our fourth quiz. Today we cover section 7.2, which is a general definition of sine and cosine, these things that we started defining last class. Currently outstanding is project number 5. So I know some folks have already started working on it. Project 5 is due this coming Friday, okay? And what else is happening? So on Friday, I will give you project 6, and then we have spring break. And then when we come back, there will be a welcome back with a quiz on that Monday morning. Yeah. All right, so on page 14, we'll go up to the top. And we'll start with Garrett. Number 1. Okay, so this picture right here, which is blank, is going to get filled in with a lot of stuff over the coming weeks. And we're going to fill pieces in, sort of one bit at a time. But we're going to use this circle quite a bit for the next, for this whole section that we're doing on trigonometry. So the first thing I want to do is label some angles. So let's say this. This angle right here is 30 degrees, and this angle in here is 15. And so if I wanted to label how much the actual angles are, starting from the I guess, due east and then rotating counterclockwise, that's a 30-degree angle there. What's the next one altogether is 45. And so all I'm looking for you guys to do is fill in that inner ring of numbers. And I will tell you that the pattern in every quadrant is 30, 15, 15, 30. That's where the lines are. So can you guys fill in some more of these numbers that I've started here in blue? Just work your way all the way around until you get back to the start. Any questions about what we're doing? Yeah, that very first line is a 30-degree line. Thanks. Thank you. All right, so I filled in all of them here, although I guess there's something off the top of the screen there. But again, the pattern is just 30, 15, 15, 30. That's, we make that pattern because we studied in the last class a couple of special right triangles. One of them is on the whiteboard over here with a 30, a 60, and a 90. And so I'm interested in having a 30-degree angle in my picture and a 60-degree angle in my picture. But the other triangle that we studied last class had what angles? At 45 and 90. So that's why the 45 makes an appearance. So we're just labeling them so that 30, 45, and 60 are in the picture. Those are the only angles that we care about besides the compass angles, 90 and 180 and 270. And speaking of compass angles, let's go ahead and fill in what's this one right here. That's 360, just continuing the pattern. So we can put 360 there. But then going backwards this way, what's that angle? That's 0. So we're going to have the same angle has two different markings on it. 0 degrees lands you at the same spot as 360 degrees. Okay, any questions on those patterns there? Okay, so we'll go to the next page. Number 2, Hillary. Okay, so the first one is 540 degrees. 540 is more than 360. So to figure out how much extra, what do we need to do? We need to subtract off 360. What do we get? 180. So a 540-degree angle is really the same as a 180-degree angle with one complete revolution thrown in. So I'll go ahead and label that on this picture. This label is going to be kind of temporary. I don't know if you even want to put it, but I'll say, this is kind of like 540 degrees. One complete revolution, and then you land on the same spot. Okay, can you guys, with your neighbors, try the rest of those? So the basic idea here is if you have an angle between 0 and 360, then it's easy enough to find on the unit circle. But if it's not between 0 and 360, because either it's too big, like the first couple of angles here, or maybe it's negative, like the last few angles here, well, then you just kind of have to wrap around and figure out what is it really. It's always something between 0 and 360. It's just a matter of finding it. So how do you wrap around? Well, in part A, you just subtracted 360 and got what was left over. Same thing for part B. If the number was like really big, like 1,000 degrees, what would you do to really get it? Because if you subtract, you just keep subtracting 360, right? If it's 1,000 degrees, just subtract 360 until you land in the right spot, which is between 0 and 360. If it's negative, we can add 360 degrees. And what we start to think about here is that negative angles are actually going which way in terms of the clock. Negatives are actually clockwise. So I'll just label one of these guys here. This 315 degree angle is really the same as, or kind of the same as, negative 45 degrees, okay? So this is just the convention. Angles always start on the positive x-axis. Positive angles go counterclockwise. Negative angles go clockwise. Any questions about any of that? Okay, so we'll go to number 3. Vanessa. Okay, let's pause right there. This is a completely brand new, completely unrelated to the definition of sine cosine from the other day, definition of sine and cosine. What was our definition of sine of an angle before? It was a fraction. What over what? Opposite over hypotenuse. Sine was opposite over hypotenuse. Now, sine is the y-coordinate of a point. Okay. So for example, if I asked you for the sine of 30 degrees, well, you would find your 30-degree angle in your picture. 30 degrees is this line right here, and you land on some point, yes? And that point has 2 coordinates. It has an x and a y to be determined. We'll fill them in soon enough. But our definition of sine of 30 is now which one? Vanessa just read. What's the definition of sine? The definition of sine is the y. So whatever the y coordinate is at that point right there, that's what we're calling the sine of 30 degrees. That's it, okay? No more opposite over hypotenuse. It's just the y coordinate. But it really is still the opposite over the hypotenuse because, and you don't need to draw this in, but suppose that I drew in a right triangle down here. And so just focusing on that red triangle and thinking about the 30-degree angle, which one is the opposite side? Is it the horizontal or the vertical? It's the vertical, so that's the opposite side. And remember, sine is opposite over hypotenuse. So I've labeled the opposite side. Hypotenuse is just that long one out there. But this is a unit circle, and it's easy to miss the fact that the word unit means something. It tells you the radius is how much? Radius is 1. This circle right here has a radius of 1 all the way around. So the hypotenuse of that red triangle is just 1. So if I think about opposite over hypotenuse, I'm really thinking about opposite divided by 1, which is the same as opposite. But that opposite has a name. Would you say that that length is the x-coordinate or the y-coordinate? It's the y-coordinate, isn't it? Like if I just said, you know, like you're standing at the origin and you go this way and you go this way, then that's like plotting the point x and y, right? X to the right, y up. So if we say opposite over hypotenuse, we're really saying the y-coordinate over 1, which is really just the y-coordinate. So this whole sine of theta is the y agrees with our definition of SOHCAHTOA. Yes, as part of our definition for the unit circle. Yeah. Okay, so let's see if I can get rid of some of that stuff because our picture is too cluttered. But anyway, the point of all that is that this is a new definition, but it agrees with the definition that we had before for sine and cosine. All right, so Let's go to number 4. Bernie.
Thus, we can label any point on the unit circle as cosine theta, sine theta. Take the circle right bar.
Okay, so each of these angles here is one of our compass angles. Do you know what I mean when I say that? Either 0 or 90 or 180 or 270. So let's go ahead and go back to the circle before we think about finding the cosine of 180. Let's go back to the circle and start filling in some coordinates. For example, think about that 90-degree angle way up there at the top. It has 2 coordinates. How much is the x coordinate at that point right up there at the top? It is 0 because we're on the y-axis. How much is the y coordinate? It's 1 because this is a circle of radius 1, and all the way at the top, it must be up 1. So that's the point 0, 1. Can you guys label the coordinates of the other 3 compass angles? Once you've got your 4 points labeled, go ahead and just check with your neighbor. You're going to be referring to this picture a lot. You want to make sure it's right. Any questions on any of those? Okay, then let's see if we can start filling in some stuff from that previous question. What was the first one? Was cosine of 180? We're asked for the cosine of 180 degrees. All right, the cosine is the most important thing for today. Cosine is x. Sine is y. That's the most important thing. Can you guys say it with me? Cosine is x. Sine is y. If it helps, if you're like an alphabetical type person, cosine comes before sine. X comes before y. Okay? All right. That won't be as awkward on the video. It'll be good. So the cosine, it's the x. You just got to find the 180-degree angle. That's this guy pointing straight left. Then you grab the x coordinate of that point on the circle. What is the x coordinate? It's -1. The cosine of 180 degrees is -1. Can you guys fill in the rest? Again, checking with your neighbors. Okay, we'll go ahead and fill in the rest. Sine of 180 degrees. Is the sine the x or the y? Sine is y. Sine is, yeah, all right, so we did the cosine. So sine is y. We want the y coordinate of the 180-degree point. What is the y coordinate? It is 0. So the sine of 180 is 0. Nothing more and nothing less. -90 isn't really on my picture, so I have to translate it to something between 0 and 360. We're going to spend a lot of time translating to 0 to 360 so it lives on the picture. I added 360 to -90 and I got 270. So really I'm looking at that point that's going straight down. Cosine, is it the x or the y? It's the x. What is the x coordinate of that point at the bottom? It is 0. And then sine of -630, I added 360. I added another 360. Keep adding 360s until you find something positive. So if you add a few 360s, you get to 90. Is that right? Okay. So, is that okay? So 90 degrees, that's the straight up point. Is the sine the x or the y? Sine is the y of the straight up point. What is it? It is 1. Okay, and 2 things I just want to observe here. First of all, this is the first time we are doing sine or cosine of anything that is not between 0 and 90 degrees. Because last class, the only thing we had for defining sine and cosine was if you're in a right triangle, you can use SOHCAHTOA. But the only kind of angles that are inside of a right triangle are acute angles, ones that are less than 90. Here we have extended. We can deal with any angle you give us, anything at all, not just less than 90. And I just want to make sure that you are aware that your calculator knows all of this stuff too. So let's go ahead and confirm a few of these. Cosine of 180, I can type that. Before I hit enter, I'm going to check what? I'm going to check that you're in the right mode. I am in radian mode. That'll have a whole lot more meaning on Wednesday, but for right now, we never want to be in radian mode, so go to degrees. Cosine of 180. Oops. Cosine of 180, -1. Okay, that's fine, and it can handle the big numbers too, like if I did sine of -630. It can deal with it and give us the right answer, okay? Questions on any of that? Okay, number 5, Chris. Okay, so let's go back to our unit circle. 320 degrees lives in which quadrant? You guys know the numbers of the quadrants? Maybe we haven't mentioned it. Yeah, so the quadrants go like this. That's quadrant 1. This is 2. Here's 3. Here's 4. The only place I ever use Roman numerals, naming the quadrants and naming the year in which a movie was made. That's all that Roman numerals are good for. Have we seen that before with the quadrants? 1, 2, 3, and 4. I'm thinking of 320 degrees. When you guys hold up the number of fingers, that is the quadrant that this thing lives in. In which quadrant does 320 live? Good. I see a lot of 4s, so 320 is down here. Is 320 is 320 one of my nice angles that's labeled? No. All right. Okay. What I want to do is just estimate where 320 is. Doesn't even have to be a very good estimate. Maybe we won't even do it on the unit circle because we don't want to clutter that picture up. So how about we use this circle up here? And I'll say 320 degrees is maybe right around there. So I'll draw that in and say that is 320 degrees-ish. If I could somehow get my hands on the x and the y coordinates of that magical angle, I would be done. Cosine of 320, sine of 320. It's really just about what the coordinates of that point are. Turns out those are not nice numbers. But we can find another angle that has exactly the same cosine as 320. So first of all, again, is cosine the x or the y? Cosine is the x. So I'm looking for another point on this unit circle that has the same x coordinate as that. I'm going to go ahead and label the only other points that have a chance. There's that one, and there's this one, and there's this one up here. So we've got 4 symmetric points, right? You got 1 point on the circle, and there's 3 others that have something in common with that point. I want to know which color has the same x coordinate as the red point. 1 vote for purple. Which point has the same x coordinate? More purples. I feel like playing Candyland for some reason. I don't know why. Okay, it is purple because the x coordinate is just saying go to the right this much, and you could go down and land on red, or you could go up and land on purple, but either way it's the same x coordinate. So the angle that I'm interested in is the one up there in purple. So if 320 is that angle all the way around there, what I'd really like to know is what is this angle in here? What is that purple angle? It is 40 degrees. And so the way to find that is to figure out what's this piece, and that's 40 because it's got to be 360 total. And then by symmetry, it's going to be the same 40 up there. So the cosine of 320 and the cosine of 40 are what? They are the same. They are equal to each other. What's that, Kyle? Okay, so Kyle has typed it into the calculator to see if this is true. I mean, we did this without a calculator, but calculator should be able to let us know if it seems reasonable. So cosine of 320 is the x-coordinate, that point, the red point. And I know that the x-coordinate out here is 1, and that red point has an x-coordinate of, I don't know, 0.8, 0.7, something-ish. So we'll type it into the calculator and we'll get the messy number, cosine of 320, 0.766. Great. Compared to what should I type in? Cosine of 40. It's a different angle. It's a completely different angle. But it's got the same exact x-coordinate, so it should have the same exact value of cosine. Questions on that? Yes. Well, the idea here is that, so we're going to study all of our trig functions, sine, cosine, and tangent, between like 0 and 90 degrees. That is going to be our focus. And the point here is that if you have an angle that's somewhere else, you can kind of translate it and get it to go up there into the well-known 0 to 90 land. That's what we're doing. Good question. All right, can you guys figure out part B? Looking for some angle where the sine of 320 is the same as the sine of some other angle. Check with your neighbors. Okay, so which color is going to have the same y-coordinate as the red point? Is blue, right? We want the sine, and the sine is the y, and the blue point over here has the same y. So we're interested in knowing what the angle is, always from the positive x-axis. That's always where our angles start. And there are actually a couple of different ways to figure out what that blue angle is, the entire blue angle. So one way I'm going to discourage you from doing, it's perfectly legitimate, but I don't think it goes someplace good. Could you guys tell me how much is in here? That's 50, right? 320 minus 270. So if it's 50 that way, then gosh, it better be 50 over on this side. And if I did the 270, which is straight down, and subtract off the 50, we get on the 220. That's right, and it works every time. I'm going to encourage you to not think about the 270 line, but rather just think about the horizontal line. Just do everything from that line. We've already seen that this angle in here is 40. So then I believe by the symmetry that this angle in here is also 40. And how do I get to my blue angle? Well, let's see, blue goes all the way around to 180 and then apparently plus another 40. So I'd much prefer to think of this as a 180 plus 40. It's the same 220 either way. And we can just write down over here that this is equal to the sine of what did we say? 220? 220. Okay. So that's good. And again, you can check on the calculator. Before we do, sine of 220 degrees. Again, is sine x or y? Sine is y. Is the y-coordinate of 320, that's the red point right here, is that y-coordinate a positive or a negative number? That is a negative number. Just thinking about plotting points, the x is positive because it's to the right, y is negative. So for the first time, I'm going to type in sine of an angle and expect a negative number. There's no way we'd get a negative number when we use SOHCAHTOA, because it all comes from sides of triangles, which are all positive numbers. But somehow the sine of 320 is supposed to be something negative. Sine of 320, negative 0.64, compared to what? Sine of 220. Should be exactly the same. Questions on that? Okay, so now I have a question. How come nobody's commented on my shirt? What's that? Casual Monday. Yeah. All right. So I'm wearing a short sleeve shirt for the first time in my career at GCC. Number one, I want to show off my Popeye-like forearms. But number two, it's the only trig shirt that I have. So here's the trig that's happening on my shirt. Sine over cosine. Sine over cosine is let's see, sine over cosine. So let's think about so this is a little aside that will come in later, but sine is which one? Is the y. All right, so sine is the y, cosine is the x, right? Okay, let's also think about sine over cosine in terms of SOHCAHTOA. Sine is what over what? Sine is SOHCAHTOA, so it's opposite over hypotenuse. Cosine is adjacent over hypotenuse. And what cancels? You see the hypotenuse cancels? You can multiply top and bottom by hypotenuse and cancels. And you get opposite over adjacent. Opposite over adjacent is supposed to remind you of something. Opposite over adjacent is tangent. So what is sine over cosine? It's really tangent. Yes, Topher. I think I did. No, we'll leave it in there. All right, number 6. Who's our reader now? I think it's Kyle. Okay, can you guys do all of these parts? Part A is without a calculator. Check with your neighbors. Okay, so we estimate a 100-degree angle in the second quadrant, but not very far into the second quadrant. And we know that the x is the cosine. So that point right up there is exactly at cosine of 100 degrees, comma, sine of 100 degrees, assuming this is a unit circle. On the next page, we'll figure out what if it's bigger than a unit circle. But if it's a unit circle, that's what the point is. Cosine of 100, comma, sine of 100. How much is cosine of 100 from the calculator? Oops, negative 0.17. And I'm hoping that we made some guess that was at least a negative number, because the x-coordinate of that point has to be something less than 0, but not too much less than 0, because at the far left, it's at -1. So negative 0.17 is reasonable. And then the y-coordinate, is it a positive or a negative? It's positive, because that point is up above. And this top point right up here is at 0, 1. And the y-coordinate of this blue point is darn close to the same y-coordinate as the top point, right? So I'm expecting like 0.9, 0.95, 0.98. I mean, it's really close to 1, right? All right, what is it? 0.98. Questions on that? Okay, this question wasn't on the packet, but let's just ask it right now. If I were to move to 101 degrees, 101 degrees, a little bit further counterclockwise, does the cosine get bigger or smaller? Does the sine get bigger or smaller? Talk to your neighbors about those questions. So how about cosine of 101? Is that bigger or smaller? It's smaller. So I mean, it's kind of like, you want to say it's bigger because we got further away from the origin, but we're going left. So it's a smaller number because it was negative. And if you type in cosine of 101, as Ali says, it's not a whole lot different than negative 0.17, but should be something a little bit smaller than negative 0.17. How about the sine of 101? Also a little bit smaller because we have moved down. Yeah, I think that's good. So just while I'm thinking of it, I'll go ahead and put up my answer key for the quiz, this one here. And one of these says rotate. How about that one? This is harder than like driving. Okay, there they are. Okay, and then we'll keep going down to the power function that hits 2 points. Let's see, over here. Sorry. Is that right? Anybody else get that one? Yeah, 180 divided by 5. Did I do that wrong? How much is 180 divided by 5? Oops. All right, scratch that. Scratch that. Okay. No, there are other ways to write the answers to these. 1058 times 12 is the same. Yeah. There are other ways. You could have used the 32-degree angle and the answers would look different. That's okay. And then on the back, what's happening here? So one of these functions didn't go to infinity, and I think it was the h1. Because the h1, what does the h1 go to? Goes to just 4, because top and bottom are the same power. So that one goes to 4. And then most dominant and least dominant. So the most dominant one, which one is most dominant? E, right? I mean, E beats everything. All right, so E is the most dominant. And the least dominant is, let's see, so the top one goes to x to 0.08, and the bottom one is x cubed over x squared, which is x. So x to the 0.08 is smaller. So I think that's the least dominant one. Yeah. Okay, so so maybe somebody got 100 on that quiz, but it wasn't me. What did I do? 180 divided by 5 is 18. How did I? It's 16. I knew I wanted a power of 2, and so it made it a nice power of 2. Okay, let's try 7. What if, let's see, so 7, we're up to Vance. Okay, so looking at this picture, again, what's the definition of sine from the SOHCAHTOA stuff? Sine is opposite over hypotenuse, and cosine adjacent over hypotenuse. So these are our old definitions, and we want to make sure we make new definitions that agree with those ones. So I guess what are we talking about here? So what is the opposite side in this triangle? That's a y, and the hypotenuse is now r. It used to be just y over 1, but now it's y over r. So so if we're thinking about that point right there, the y coordinate is what I'm interested in filling in. It's got a question mark on it. If I multiply both sides by r, then this r will go over there. So I get y is equal to r sine theta. By that? So we knew sine was the opposite over hypotenuse, which is y over r in this case. So if I wanted to figure out what the y coordinate was, I just multiply by r. Likewise, the x coordinate is r times the cosine of theta. This isn't too far from our definition in the unit circle. What was the definition of sine theta on the unit circle? It was just y. So y equals sine theta is what we had written down before. That was our definition. Okay, that's if the radius is 1, you don't have to write it there. But if it's anything other than 1, you have to put it. So I guess what I'd like to put in here is that the x coordinate is r times the cosine of theta. And the y coordinate is r times the sine of theta. Okay, so we'll go to Sarah for number 8. Okay, so we've got this same setup that we had before. And we're trying to figure out where this car is, how high the car is at any angle theta. All right, initially, and remember the diameter is how much? 20? 20 is the diameter, so that's a 10 in there. So like initially, how high is the rider off of the ground? It's 15 meters off the ground, right? Initially, 10 plus the 5 is 15. So we're trying to come up with some formula, where like the input is theta and the output is the height. And we've already figured out that if theta is 0 degrees, meaning we haven't rotated at all, then what was the height? It's 15. You could just jump to the answer if you want to. It's all right. So if we're up at the top, if we're at 90 degrees, how high is the rider off of the ground? It's 25, right? 10 and 10 and 5, so that's a 25. If you rotate your way around to 180 degrees, that's straight left. And what's the height? It's again 15. And so we want to come up with some formula that captures this, but doesn't just deal with 0 and 90 and 180, but deals with all the angles in between. I should be able to figure out, if I'm like 4 degrees up, I should be able to figure it out. How can I figure it out? Well, I'm gonna just, you don't need to write this, but temporarily, suppose that I put like an 8-degree angle up there. We've rotated just a tiny bit. Are we a little less or a little more than 15 meters off the ground? A little bit more, we've gone up just a tiny bit. How much more? Well, how much more we've gone up is this vertical distance right here, right? Thinking about the coordinates of that point, is the vertical distance the x or the y? It's the y. So what I'm really interested in is knowing what the y is. But we've already figured out that whenever you're on a circle and you have an angle, the y is r times the sine of the angle. That's what we just did right up above. So can you guys use your calculators? Instead of r, what do we have? 10. Instead of theta, in this example, what do we have? 8. Can you guys type 10 sine of 8 on the calculator? And whatever we get, that's how much we have risen. Shouldn't be very much. 8 degrees is pretty small. How much is it? Okay, so about 1.4 meters is how much we have gone up. But we were originally how far off the ground? We were 15 already. So it feels like it was, let's see, am I doing that right? Is it 5 plus or 15 plus? 15 plus, yeah. So we were 15, we just gained another 1.4, so now we're at 16.4. Well, let's just do it in general. Instead of 8 degrees, let's go back to calling it what? Just call it theta. So here's our formula for the height. I know it's the y coordinate. I know the y coordinate is r sine of theta. Instead of r, it's 10. 10 sine of theta. But that doesn't take into account the initial height that I had. Again, how high were we initially? 15. So I think if we just do a plus 15 there, we've got our formula. Now I hesitated myself, was it a plus 15 or a plus 5? You know, like it's a plus 5 the whole wheel, but then there's a 15. What happens if we're below the starting point? Well, let's see what happens. Suppose you were to type in 270 degrees. 270 is the straight down point. I know what the answer is supposed to be. How high are we supposed to be when we're at 270? We're supposed to be only 5, because we're right down there at the bottom. If you type in sine of 270 on your calculator, you'll get -1 times a 10, -10, plus 15, 5. So I think that this formula gives it to us. 5 plus 15, because 15 is the middle. It's not really about where the bottom is off the ground, it's where the middle is off the ground. So 10 sine of theta plus 15 is our formula that tells you how high you are for any angle theta. Questions on that one?
It's just like a function.
Yes. Yeah, and so Garrett is now starting to think about the graph of sine, and we'll talk about the graph of sine quite a bit. But it is a function, and you could graph it. And I bet you guys right now could even start to get a sense of when is it going up, when is it going down, when is it positive, when is it negative. But it is a function shift. That plus 15 is just moving the whole thing up 15. Okay, can you guys try number 9? We'll get a reader first. Richard? Okay. Do you guys remember these words? Amplitude, midline, period, all that stuff? Okay, so the definitions were in the previous section. If you need to refresh your memory or ask a neighbor, and see if you guys can come up with answers to that.